All right. Happy Tuesday, everyone. Thank you for joining the Data Platform and Analytics partner call for December. Before we get going, we would just want to do a quick little sound check just to make sure everything on our end is working. So in the Messages tab, if you guys don't mind typing in your favorite part about the winter season, that would be great. Thank you. And as the answers go in, that's always good to see. And a very cheerful time of the year, seeing some skiing, some eggnog. I love it. Perfect. Thank you, guys. So good to know that works. And before I hand it over to Sri and Diana, who will be leading this call, I just want to give you guys a few logistical background pieces of information. And so first off, just want to let you guys know that this call is being recorded. So if you guys have any sort of issue or problem being recorded or potentially having your name or email being shown at some point throughout the call, just by chance, I would highly recommend that you hop off the call now. The slide deck and this recording will be available on our Yammer page and our YouTube page as well, so you can access that information after the fact. But that is all for that. And if you guys have any questions throughout the presentation, feel free to type those in the Messages tab. We'll receive those on our back end and respond to those accordingly. So just to let you guys know about that, we are not ignoring you, just trying to keep things going in a timely manner and be mindful of your time as well. With that, that's all I have with logistical. So Sri, I'll pass it off to you.
Thank you, Parker. Welcome, partners. Good morning, good afternoon, good evening, depending on which time zone you're joining from. Really excited to kick off the December Data Platform and Advanced Analytics Partner Community Call. My name is Sri Ganapathy. I'm the Data Platform Community Lead, and I have a team of folks here at Microsoft that work with me on these community efforts. I also have my peer, Diana Phillips, who's going to be leading some of the presentation today, and I'll ask her to introduce herself a little later. So together we're going to be kicking off today's call. Before we get into the core topic of today's session, which is around IoT and Internet of Things, I wanted to share a few updates and information about some of the community efforts that are going on. The slide that you see right now, talks about the different ways to engage with the Microsoft partner community. So there are different practice building areas that we focus on. As you can see on the slide, we have application development, Azure infrastructure, data platform, etc. This is the data platform and advanced analytics call, obviously, and focused on partners that are interested in building solutions in that area. We have a number of ways to engage partners with. The community calls that you're listening to today is one way, and I strongly encourage you to continue participating in these calls going forward, and please invite your colleagues and other friends. There are other ways also that you can engage with us on. We have a blog series, and Diana, myself, and I have two of my peers, Sadie and Subhash, who are also on the call. We all, post monthly blogs, sometimes bi-monthly also, depending on, key topics that are of interest to partners. So that's another way of staying up to date with events around the data platform community from Microsoft. We also have a Yammer group, which, is more interactive, and you can ask questions and any comments or feedback, that's another way for you to engage with us on. And we have a number of training and enablement initiatives, and I'll talk about a couple, shortly here, but, that link that you see on that slide also is one-stop shop for you to go access all the different information about our training that we offer for our partners. We also have business-oriented communities, which you can see at the bottom of the slide. So different ways for partners to stay engaged. This community call is something that something that we host once a month, and this is one place where we also get guest speakers and from the product team, like you will hear shortly today. So this is really straight from the from our engineering teams, and a lot of good information that I don't want you to miss out. So please make sure that you let your partners and other friends know about it. All right, with that, I'm going to talk about a couple of things that we announced, in the recent past, in the last couple of weeks, and we did blog about this and put it out on the Yammer. But I also want to highlight it today in the call. Azure certifications are something that a lot of partners are interested in. It's one way for you to stay up to date and also attain some of the competencies. And we actually redesigned some of these Azure exams. So in order to help partners take some of these exams, we also have some offers that are available right now. From a training perspective, in order to get ready for these certifications, we have a number of online courses. And again, I'll share this deck, and you'll have access to this deck with all the links. You can go there and access a lot of the online catalogs that'll help you prepare for some of these Azure exams. But as far as taking the exams itself go, we have some vouchers that you can see on the slide. Depending on whether you want just one exam or more than one exams, there are some discounts available right now for you to take advantage of. And so I'd strongly encourage anybody that's looking at getting certified on Azure to go through these online courses and also take advantage of these vouchers, so that way you can get these exams in your plate. I have some more slides here that I'm not going to go through. It's more for reference on the different topics that these online courses cover, and also the different certification exams, and a link where you'll find more information on each of those exams. And then, the last but not least, I also want to talk about a couple of other training opportunities that we have coming up. There is actually a webinar tomorrow that I would strongly encourage you to also attend if you have the time, on Microsoft machine learning. This is a recent announcement that we made, and something that a lot of partners have expressed interest in. And so the link there is for you to go watch it live, but you can also access the recording later on if you cannot access during that time. So another great training opportunity for partners. Something else that my team here is working on is putting together some on-site in-person training events for partners, and focused on some core topics like SQL 2016, Power BI, Advanced Analytics, and IoT. These are called Partner Practice Enablement, or PPE boot camps, and we're going to do a number of these in Q3, which is basically in the Jan, Feb, March timeframe, but more likely in February and March. And we will have dates and locations announced here pretty soon. So stay tuned, either on the Yammer posts or blog posts, or one of these community calls will have more information. These are all free training offers. In person, we'll have a number of instructors coming in, over a period of a couple of days, 3 days, etc., in some of the Microsoft locations in the U.S. to train partners. So some other training opportunities for you to take advantage of. The last one is around the Oracle Migration Bootcamp. We did one of these in New Jersey a couple of weeks ago, and it was very successful. We had a number of partners that are interested in building data platform opportunities, but also at the same time interested in learning about what our competition is doing and how to maybe modernize some of these customers' environment by moving those workloads also to the Microsoft stack. So Oracle is one such area where we focus on, and we had a 4-day boot camp training a lot of the architects and other technical resources, and also the sales and marketing resources in building an offering, or if you have an existing offering, how do you also incorporate compete skills like Oracle, etc., so that you have a well-rounded data practice. We have one more of that boot camp that we're going to have in Chicago in February. Again, dates and links and registration, stuff like that, are going to be finalized here in the next couple of days, and I'll send an update. But if you're interested, again, feel free to reach out through one of the different touch points that I mentioned, Yammer, blogs, etc. You'll have access to these slides again, so you'll have my contact information as well. So if you want to reach out to me directly, that's fine. So those are the announcements that I wanted to make. If you have any questions, again, use the Q&A panel, and we will address some of these questions in the end. But with that, I want to hand over today's next presentation to Diana Phillips, who's one of my peers. And Diana also has somebody from the product team who will be presenting this along with her. So Diana, the floor is yours.
Great, thank you. So today we're going to be talking about how to use real-time analytics with your Internet of Things solutions. And so I know some of you may not be familiar with IoT and what's available there. Hold on one second, let me get the slides back up. Okay. Passing control is sometimes tricky. All right, so I want to just provide you with a quick overview of IoT for those that are not familiar with it. So within the IoT landscape, obviously you have things. These could be devices. This could be machinery in a factory. And whatever those devices are, there's valuable information usually picked up through different sensors. And for the Internet of Things, the key here is connecting that so that you can pull the information from those devices, and then you can start utilizing the data. So the data is centralized, usually stored in some big data solution, and then you'll do analytics against it to start making value and recognizing patterns. So the analytics may be batch analytics using machine learning, or it could be real-time analytics as the data is in motion through the system. And then based on the findings through the analytics, there are actions that will happen. That could be preventative maintenance, could be something related to fleet management, etc. So when we look at the Internet of Things overall, there's huge opportunity out there. So if it's not an area that you've gotten familiar with yet, there is some value you may want to look at. I'll post some links here so that you can go and do some additional research and see if that's something that you want to get involved in. So within the Internet of Things, a lot of people are pulling sensor information in and understanding what's going on. But there's so much more potential and opportunity there. So this diagram shows as you progress and make your systems smarter, you can go from just descriptive to diagnostic to really becoming predictive in nature, where you can predict before you have a failure, for example. And you can be prescriptive to recommend smarter solutions or optimizations. And so these second two areas, those are the ones that go along with the real-time analytics that we'll be talking about today. And just to understand, with all of the opportunity out there, the spending today in some of these different industries, this slide shows the power of 1%. It could be 1%. Sheree, we can't see the slide. It could be a 1% savings. It could be an improvement in efficiency, and because of the volume of money spent in these areas, you can see the billions of dollars related to some of these savings. So there's a lot of opportunity for partners to build solution offerings that can really save customers a lot of money in these industries. And then just so you understand what we're going to be going through, we are going to be focusing on Stream Analytics, which is an Azure service within IoT Suite. And for the reference architecture here, you can see when data is first coming in through IoT Hub, Stream Analytics is the tool that can really process that real time. And then Stream Analytics is also part of the Cortana Intelligence Suite. So now I will turn the time over to Sam. He's from our Azure Big Data team, focusing on Stream Analytics. Sam, are you muted?
Yes, I am. All right. Thank you so much, Diana. Hello, folks. My name is Sam Chandrasekhar. I'm from the Azure Stream Analytics team, and I'll walk you through what Stream Analytics can do for you and the value that it can unlock for you. Like Diana highlighted, the whole IoT space is all about sensors generating streams of data. Stream Analytics is the premier Azure offering that can enable you to unlock predictive insights from these streams of data. Now, if you look at real-time streaming itself, this is a fairly new construct. It's a fairly new concept. The past was all about batch processing. So if you needed to ask questions on your data that was streaming in from multiple sensors, the paradigm of the past was one where you collected all of this data, you aggregated it, and you stored it in some sort of a repository where the data would be at rest, and then you would reason about it. This whole new paradigm of real-time streaming enables you to ask questions about your data as the data is in motion. In this new world, Insights are perishable, and getting time and the time to insight is even more critical than ever before. So by enabling you to ask questions on your data while it is in motion as opposed to waiting for the data to get to rest, we can unlock insights faster and reduce decision latency. And this is essentially the core of what Stream Analytics and other real-time streaming products and solutions on Azure have to offer. You know, in the real-time streaming space and the IoT analytics space, there are plenty of scenarios, but the most important ones are regarding complex event processing. Folks have had simple event processing for a long time, where they've been performing simple operations such as filtering and transforming and enriching data as they move it from one entity to the other. With Stream Analytics and a bunch of other Azure solutions, we are able to provide a fully managed service for complex event processing, where you'll be able to join multiple streams, where you'll be able to have a temporal semantics on these streams of data coming in, where you'll be able to perform correlations, look up reference data, and things like that. And I'll talk about some of those details going forward. All right, when it comes to the scenario categories that this can operationalize and this can unlock for you, there are really two broad modalities. There is a category of scenarios where humans get to ask questions on their data, and essentially you can have a real-time dashboard or a live visualization of some sort that will enable humans to perform their job better. There's another category where the whole loop is automated, and real-time predictive insights can drive automated workflows, thereby getting rid of the human in the picture and totally automating the entire loop. What you see on your screen right now is a set of examples for scenario possibilities that have already been operationalized with Azure Analytics by several partners and customers around the world. Real-time fraud detection is big for us, both in the telecom sector as well as the financial industry, for detecting credit card fraud and things like that. Our latencies are small enough to the point where in a matter of seconds, even before the transaction actually occurs, it is possible to preemptively detect and prevent fraud. Predictive maintenance is a big IoT scenario for us. As you're all aware, the industrial Internet of Things is catching on like wildfire, to say the least. And what we're noticing is that companies are bombarding and almost carpet bombing their devices with tons and tons of sensors that are streaming in telemetry data to the cloud. And using that telemetry data, they're able to sort of get an intimate understanding of the field performance of their devices and of their plants, thereby sort of scheduling preemptive as well as predictive maintenance before even a failure occurs. We've done a bunch of case studies that also come with the monetary savings that these partners and customers actually experience. The most predominant one is with our partner ThyssenKrupp, who perform predictive as well as preemptive maintenance on elevators by performing analytics on streams of IoT data. There is another industry that IoT analytics is disrupting, and this is sort of airlines and airplane engines is one prime example there. In the past, device manufacturers would sell devices to customers, and it was a one-time transaction, and then they'd sell them support contracts and things like that. In the new world, what we are noticing more and more is a case where the device manufacturer is selling the device as a service. So if it's an airplane engine, the engine manufacturer is selling thrust hours as opposed to the engine itself. It's almost a subscription service for devices. And from the perspective of the consumer, this removes the headache and the cumbersome aspects associated with upkeep, maintenance, servicing, etc. And more determinism when it comes to the financials. And at the high end, we partner with Rolls-Royce, and GE does some of this on their own. but thrust hours for airplane engines is a big scenario. And you see a lot of scenario possibilities. I won't get into the details of each one of these, but one thing that I'll highlight is connected car scenarios and fleet monitoring. With Stream Analytics, we now have support for geospatial capabilities that allows you to reason about GPS data coming in from moving objects. And you can ask questions about it and get answers in real time and either kick off automated workflows or alert humans. Going forward, if we take a 30,000-foot view of what a Stream Analytics pipeline looks like. Oops. So this is what it looks like. So you have data exhausts, such as devices and gateways or applications or log data or clickstream data that is all streaming in data to the cloud. And we have a layer for event queuing and stream ingestion. So we have support. We have this fully managed Azure service called Event Hubs. IoT Hubs is a service that is very similar to Event Hubs, except that it's bidirectional to the point where you can send control messages back to devices. So these are low latency buffering and queuing systems that events that stream in from devices come and sit at. And then you have a solution like Stream Analytics that picks off these events to be, and you can articulate your logic to ask questions about this data that is streaming in using Stream Analytics. And optionally, you can also call out to machine learning modules to perform real-time scoring of streaming data as it is coming in and get near real-time outputs. And the three most common modalities that we see for outputs are either archiving to batch storage, to the point where you can actualize what we call a lambda architecture. If you look at the Greek letter lambda, it's sort of one line splitting into two. And that is essentially what we have here as well. There is the speed layer or the streaming layer, and then you ask questions about your data that is in motion, and then you also have a fork of the same data being stored at rest so that you can ask questions about the same data at rest at a later point in time. And potentially those questions could be more profound and more powerful in some ways than the streaming questions. So you can perform both streaming analytics as well as batch analytics on streams of data coming in using Microsoft solutions. Power BI is our dashboarding solution, and Power BI provides mechanisms for live visualization and real-time dashboards that will enable you to operationalize a command and control console for all aspects of whatever you're monitoring. And the other third category is kicking off workflows. You can either kick off workflows with Azure Functions or worker roles by writing to service bus queues, etc. So this is sort of the streaming pipeline. We've also just announced the public preview of Kafka as a service on Azure under the HD Insight umbrella. So that is another candidate source for event queuing and ingestion that Stream Analytics and other streaming solutions can read off of. It is also possible to augment incoming streams of data with a bunch of static data, such as reference data. To give you an example, let's say there is a toll booth where cars are passing through, and through a mechanism such as RFID, it's possible to elicit and extract number plate information. Now, this is the streaming component. However, if you want to combine that with another static source, let's say a license plate database, to make a determination as to which cars have license plates that have expired. Now, the license plate database is a large database that represents data that does not change very frequently. So you can mark that as reference data and perform joins on streaming data along with reference data and ask powerful questions. Going forward, there are lots of streaming solutions and real-time streaming platforms in the market, some on Azure and some from our competitors. I want to focus on the differentiated value proposition of Stream Analytics. And really it comes down to a few things. The first one is programmer productivity. With Stream Analytics, this is what we've optimized for. With most other solutions, it is necessary to write hundreds, if not thousands, of lines of code in either Java or Scala or a higher level language to operationalize a simple pipeline. With Stream Analytics, we have native support for SQL that will enable you to write declarative SQL, which is, in our opinion, best suited for reasoning about data in motion. We also have certain inbuilt functionalities like temporal windows and aggregation functions that I'll talk about in some detail going forward, that certainly reduces the amount of effort it takes for a person to actualize and operationalize a Stream Analytics job into production, not just to toy around with it. We also have a bunch of adapters for various input and egress sources that can be operationalized and actualized using a few clicks of a button. It's also a fully managed service. We believe in this notion of a job service. So if you look at the big data space, there are two categories of services. There are services that folks call cluster services, and there are services that folks call job services. The Microsoft take on big data services is very much inclined towards the job service offering front. Now, we also have cluster services provided on Azure, but the first-party Microsoft services are all job services. And the difference there is that in a cluster service, when you ask for, let's say, a Spark cluster or a Hadoop cluster or a Storm cluster, essentially what you get is a cluster, a fully managed cluster that is given to you. If you want to change the topology of that cluster, you will have to go ahead and manually make that change. If you want to scale that cluster, it would be the responsibility of the user to add more nodes to that in the currency of virtual machines and things like that. There are some monitoring and logging primitives, but in many ways, you're left to yourself there. With a job service, typically it's a fully managed service to the point where all you have to do is articulate your processing logic, and things like scaling, things like monitoring, things like logging, and all of that is taken care of for you. But things like uptime, things like provisioning is taken care of for you under the covers by the service provider, in this case Azure, thereby simplifying a lot of the workflow and thereby reducing the total cost of ownership. One of the things that Stream Analytics comes with is an enterprise-grade SLA. So we say that we will provide it, at the very least 3 nines of availability during the year. So I spoke about programmer productivity. What you see on the right-hand side of this slide is an example. So we rolled up a solution using Storm, and then we rolled out an identical solution with Azure Stream Analytics. And the difference in terms of the amount of effort it took was quite profound. With Storm, it took us about 2,000 lines of Java code to get a fairly simple task that involved a bunch of projection, a bunch of filtering, a bunch of time-based aggregations. And you see, with Stream Analytics, it's 3 lines of SQL. So that is the extent of the productivity improvement with Stream Analytics, and that directly translates to fewer people that will have to be invested towards getting a solution up and running, and thereby we believe we have the lowest cost of ownership in the industry for a stream processing solution. I spoke about declarative SQL, and I want to talk a little about that. So what we have done is we've taken the same kind of SQL that you're used to with SQL Server or any other database offering, and we have enhanced that with certain temporal semantics and aggregation functions that we think would be super useful in streaming scenarios where you're trying to ask questions about data in motion. Typically, with data in motion, you're dealing with the currency of events, and every event has a timestamp, and that is where the importance of temporal semantics comes in. Even when you ask questions about streaming data, you mark out a specific section of your timeline, and then you ask questions on the data in a window contained along that timeline. So we have enhanced the SQL language, and we call our offering SAQL, Stream Analytics Query Language. And what you see is a subset of the aggregation functions for date manipulation, geospatial operations, windowing, etc. We'll get into some details and some examples to substantiate this better, but this is what Stream Analytics has to offer. I also mentioned a mission-critical reliability SLA, an enterprise-grade SLA. We have 3 nines of availability. We have an automated checkpoint and restart mechanism under the covers. So if there is bad data sent, or there are lots of scenarios where there could be an internal restart. However, in all of those cases, we provide guarantees that there is no data loss. And Stream Analytics also comes with an at least once processing semantic, so you can be rest assured of the fact that your data would be processed, or no data will go unprocessed. We're available globally in a whole bunch of Azure regions, including the sovereign clouds in Germany as well as China. Right now, we're in 19 Azure regions, and our footprint is growing as we speak. We also meet a whole bunch of global compliance requirements, including HIPAA. For talking about the capabilities of the Stream Analytics job, I'll take advantage of a certain scenario. And the scenario in question here is a toll booth. Let's assume that there's a freeway with multiple lanes, and each lane has a tolling station. And this tolling station has an RFID reader that is able to capture license plate information of vehicles that are traveling through that tolling station. Now, when it comes to asking interesting questions about this data in motion, you'd use what Stream Analytics calls a job. A job is sort of the basic unit of what you can use to operationalize this data pipeline. So a job has inputs, it has outputs, and it has a query that basically runs for perpetuity, where you articulate your processing logic and ask questions about your data. Now, in this case, I told you about the toll booth. So for the examples that I'll walk you through, what you see on the screen in terms of entry stream and exit stream and reference data, this is the data that we'll be dealing with. Entry stream alludes to the data that is being captured by a sensor as vehicles are entering each tolling station. And there's one tolling station per lane. And then there's an exit stream that's also capturing data for that specific lane. We also have the commercial license vehicle registration data that we call out as reference data. Now, let's say, I'm going to skip this part for a little bit and then come back to it. Let's say, you want to ask the question, from the incoming stream of data, find vehicles that meet this criteria. It is as simple as articulating this in SQL and performing the right filtering operations. Similarly, if I want to ask the question, report the time in seconds required for vehicles to pass the toll booth. Essentially what I'm doing is a temporal join. I'm performing a join on multiple streams of data. And for these sections, I'm going to work with the presupposition that folks on the call are familiar with SQL. If you're not, drop a message in the chat box, and I'll spend more details on the SQL specific areas here. But the core idea here is you can perform joins on temporal windows by specifying this window. So what you see as date diff right there is a certain window that we're specifying. So we're performing a join between two streams, the entry stream and the exit stream, and we're asking the question. Similarly, we can perform other interesting operations like left outer joins, which is useful for detecting patterns. In a left outer join, there are some fields that are marked out as null, and these indicate the absence of events. And in this case, we're reporting cars that have entered the toll booth but have not exited in the past 5 minutes, things like that. So I have lots of examples like this, but what I want to focus on for a couple of minutes is this concept of windowing, which is very core to stream analytics because, in real-time stream processing, we deal with things in the currency of events, each of which is associated with a timestamp. So we have three kinds of windows. We have a tumbling window, which essentially is a window of a fixed size that sort of is used for performing processing at a specific cadence. For example, if I were to ask the question, every 10 seconds, give me a count of vehicles entering each toll booth over the last 10 seconds, I'd use a tumbling window. And the image that you see on your screen is, I think, self-explanatory in terms of what it does. We're performing an aggregation within this window that we specify. And this is articulated in the group by statement that is used in your SQL-like query. Similarly, we have something called a hopping window. If the cadence at which you want the same answer is increased, instead of a tumbling window, you'd use a hopping window. And again, the image that you see on your screen illustrates what that does. We also have this notion of a sliding window, where an output is generated every time an event enters or leaves the system. And this is super useful for detecting patterns in advanced scenarios and things like that. Now think about this. You're trying to answer the question, find all toll booths that have served more than 10 vehicles in the last 20 seconds. In a competing solution, something like this would take several hundreds of lines of Java or Scala code. With Stream Analytics, it's 4 lines of SQL. And to operationalize the pipeline itself, it's a few clicks. You choose your inputs, you connect the right inputs, and boom, you have your solution. And then you can choose to output to Power BI or kick off workflows or generate reports, things like that. I also have a bunch of advanced query examples. I will not spend too much time on this in the interest of time, but I'll demonstrate to you some of the capabilities and some of the questions that you can ask using Stream Analytics. So you can determine if a value has changed. We have functions like lag, etc. You can find the first event in the window, in a certain window, find the last event in a certain window. You can do things like detect the duration for which a specific condition occurs. In this case, we say, find out how long, let's say, a bug resulted in cars having incorrect weight. We want to compute for what duration that bug lasted. Things like so the possibilities are really profound. There are lots of very, very complex conditions that you can detect and query for using Stream Analytics, and we have a whole bunch of query samples just overall solution sets that you can readily deploy. Some of it is available in the Cortana Intelligence Gallery, so it's almost a one-click deploy. So for instance, if you want to do customer churn detection or telecom fraud detection and things like that, we have ready-made solutions that is available in the Cortana Gallery, and with just a single click, it's deployed to your local Azure subscription for you to try it out. Finding missing values is one. So those are some examples. I spoke about reference data a little while back, so I want to talk more about it. The core idea here is that you can join incoming streams of data with static data and ask powerful questions. And again, join is a fundamental capability in SQL, and that is what's used here. To highlight this with an example, essentially, if you want to ask the question, report all vehicles that have entered the toll booth with expired license plates, you would perform a join on the incoming stream of data and compare that with the license plate database and look for which ones are expired. In addition to SQL, we also have the ability to ask questions with custom code. Let's say for whatever reason, SQL is not your cup of tea, or if the capabilities of our query language are insufficient in terms of inbuilt functions and things like that. We have the ability to ask questions using JavaScript now, and we are in the process of onboarding more languages. C# and Python are top on our list. But right now, what's already available is the ability to write user-defined functions with JavaScript that you can use to augment your stream analytics query. There are what you see on your screen is an example of how you'd use JavaScript. So there is a user-defined function. You'd use that almost like a SQL aggregation function, and then there'd be a definition file where you go out and specify the corresponding logic for that user-defined function. This functionality is in private preview, so feel free to send email to the address that you see on your screen, and we're happy to unlock it. We also have the ability to integrate with Azure Machine Learning, which is Microsoft's fully managed service for actualizing and operationalizing machine learning models. There is also a rich ecosystem of existing models that have been built by folks at Microsoft and folks outside that you can take advantage of. The two most common examples of using machine learning with streaming data are for the purposes of either anomaly detection or sentiment analytics. Now, if I could show you a demo, I have a demo of Twitter sentiment analytics. So you specify a hashtag, and then we'd push it through a sentiment analytics model, and then there'd be a number to indicate the sentiment, 1 for positive, 2 for negative, something along those lines. And we have a Power BI dashboard where you can monitor the live sentiment associated with a certain hashtag or a certain keyword in near real time. And using an Azure Machine Learning module in your Stream Analytics query is as simple as a function call. Now, you would have to bind that function call to an Azure Machine Learning endpoint, and you can perform real-time scoring of data coming in. We also have some similar models for anomaly detection. The difference with some anomaly detection models is you can perform both training as well as scoring. It's almost continuous learning against a stream of data if you choose to deploy such a mode. We also have geospatial capabilities in Stream Analytics. This is also in private preview, but we're happy to unlock it for anyone who writes to us. It is public that this functionality is in private preview. So there are a bunch of scenarios that geospatial analytics opens up. The most common ones are geofencing as well as connected car scenarios. We have fairly large companies that do ride sharing, almost Uber-like services in other geographies or for other purposes than just matching drivers and riders that are using this in production already. We have race car teams that use our geospatial solutions in production already. But geofencing is a very common use case where you can draw out a boundary, and if a certain entity with a GPS signal either enters or leaves, that you can generate an alert. It's useful for security monitoring. It's useful for enforcement of licenses and things like that. We have partners that sell CNC lathes, and when the lathe or the device in question is outside of a specific geofence, it ceases to work because it fails the attestation test as data is sent to the cloud to perform the check that whether it's in the fence that the operators want it to be in. So fleet monitoring is a very big scenario. Again, if I could show you a demo right now, I have a demo of a fleet monitoring solution where we have a fleet of several trucks around the country, and you can ask questions such as, all right, show me all the trucks that are in the state of Colorado. Or you can perform joins with things like temperature data and traffic data that is also streaming in, and say, all right, show me all trucks that are stuck in a traffic jam, or show me all trucks that are, maybe, these are ice cream trucks, and you can say, show me all trucks that are in states where, or are in locations where the average temperature exceeds a certain threshold. And you can get your answers on a map. Since Stream Analytics supports outputting to Power BI natively, on a Power BI dashboard, you can get real-time answers about geospatial data, as with any other kind of data. Other big scenarios are in the connected car and connected truck industry. So we have partnered with very large car companies, and they have some very interesting scenarios in production already. So what you see on your screen is are some examples of using Stream Analytics to realize some very interesting connected car scenarios. So you can say things like, when a car is running low on gas, and if a gas station is within close proximity, you can generate an alert to the driver, letting them know about that. Or we have a partner that has put this scenario into production. Every time a car makes a hazardous, or if a certain number of cars perform a hazardous braking operation at a specific intersection, they send out alerts to all other cars that have availed to their service within a 3-mile radius that there could potentially be hazardous driving conditions at this intersection if they're headed towards that intersection, things like that. Or, joining car location data with weather information to provide actionable guidance in terms of, all right, there's a storm heading your way, you might want to change course, things like that. And again, all of these are examples of scenarios that have already been put into production and are running as we speak right now. Now, I told you Stream Analytics is a fully managed service. So we have inbuilt capabilities for monitoring and troubleshooting jobs. We have lots of metrics for jobs, and you can have conditional alerts on metrics. So if you can say things like, all right, if my job is not outputting data for a certain duration, I can have an alert, and that alert in question could be an email that is sent to a specific account, things like that. In the past, one of the most common asks that we had gotten for Stream Analytics was to improve our debugging experience, and we've just launched this capability where you can have a job diagram, which is a visual representation of your query pipeline broken up into individual steps, and you can have metrics for each step. So for whatever reason, if your query is not responsive or is not producing the result that you expected, you can look at the job diagram, and then you can look at, it gives you a one-screen snapshot of the health of your job and the health of individual components of your job and specific steps. And you can click around and open up partitions and look for metrics. You can see which steps are getting inputs but not producing outputs at the cadence that you want, and things like that. So it's a tool that is super useful for advanced debugging. And we've gotten a lot of positive feedback. Again, this functionality is in private preview. It's behind a flag, so I have the flag on the slide deck as well. So feel free to use that URL with the flag below, and this job diagram with metrics will show up. Again, it's a fully managed service, so aspects such as scalability is taken care of for you. To add, if you want to add scale, it's a matter of using this artificial unit that we have called streaming units, and it's a matter of just increasing that from the UI, as opposed to a cluster service where you'll have to explicitly choose a virtual machine of a specific size, add it to your cluster, articulate how you want your cluster topology to change, and things like that. Streaming units is also how we charge our users. I'm going to go quickly over these sessions because I want to leave some time for these sections because I want to leave some time for Q&A. You can partition your query both vertically as well as horizontally. Vertically in the form of steps, as shown on the screen, or horizontally in the form of partitions. So you can have concurrent versions of the same query running against different shards or partitions of an input source like Event Hub or IoT Hub. This is a fairly advanced topic, so I won't get into the details of this since we only have a few minutes left. But we have plenty of documentation, and I'm happy to answer specific questions that you might have, or if in the end we have a little more time, I'll go with this. The last topic that I'll talk about is out of order and late arriving events. In Stream Analytics, it's possible to specify a certain tolerance window for events that arrive late. So you might specify a window for your processing and your computation, but if that window does not get filled up, or if events arrive late or out of order, you can explicitly specify a policy to either adjust the timestamps for the events or to drop certain events and things like that. Yep, I'll pause there and open it up for questions. You can use Stream Analytics from the portal or an SDK or PowerShell, you name it. Diana, do we have any questions?
Nobody has posted questions yet, so I think you've given a really good description. Does anyone have some questions? Go ahead and just type them in the window.
All right, if we don't have questions yet, I'll talk about one other topic, which is Edge Analytics, that might be interesting to a lot of folks. Stream Analytics is a cloud resident service. Now, we also have a version of this that can run locally on satellite IoT devices or gateways. Any entity that can run the Azure IoT Gateway SDK can also support a version of Stream Analytics that can run locally. And this is super important in a whole bunch of scenarios where a round trip to the cloud is prohibitively expensive because you're on an oil rig and a satellite link is costs a lot of time. Or there could be scenarios where the latency associated with a round trip to the time itself is prohibitive for the scenario in question because you want really quick decisions. Or it could be a case of meeting compliance needs and things like that. So it is possible to run a pared down version of the Stream Analytics engine on a device with about anywhere between 2 gigs of RAM would work as well. So it's not just Edge Analytics from the perspective of running it on a server, but this can also run on much smaller devices, especially in manufacturing plants and oil rigs and scenarios like that, where internet connectivity could be bursty. And in those cases, the synchronization of the data stored locally based on the local computation with the data in the cloud and the global computation whenever there is internet connectivity. And this is, again, new functionality that we've just announced. So Diana, if there are no questions, then well, that's mostly what I had.
Okay.
So what I will end with is an offer, which is that from the product team, one of the things that we're doing is directly interfacing and working with partners to provide architectural guidance, to provide hands on deck to build proof of concepts for various scenarios. So if you're interested, don't hesitate to reach out to me. My email address will be on your screen shortly. So that is Stream Analytics for you. Since we have, I think, a few more minutes, I can also talk about other streaming options on Azure. So on Azure, we offer a whole bunch of solutions through both HD Insight as well as Azure Stream Analytics, and there's a trade-off associated with every service. Stream Analytics is a fully managed service, and then there is HD Insight, and there are cluster services. Now, based on the application in question, one or the other could be a better fit. But I want to end with saying on Azure, we are all about giving you the choice, and we have streaming solutions in addition to streaming analytics. So that's all I had for now, Diana.
It looks like there are 2 pending questions. Let's see. Someone is asking about any detailed examples around well-bore data for predictive analytics to reduce downtime, etc. And then another person's interested in finance fraud detection. If you have any more to say about that, or if you want to just follow up with them separately.
Certainly. So for finance fraud detection, what we have is a sample that's already available. So I can send you, I can send across a pointer to the sample that you can try out yourself. But the idea is as follows: that we are able to detect fraud before it actually happens, and ensure that fraudulent transactions are caught before they occur on the evidence of historical data. It takes advantage of a machine learning model that we have. On the other question, do we have examples of scenarios where stream analytics is used to prevent downtime and things like that? Yes, I have a bunch of slides on customer stories. So we have partnerships with ThyssenKrupp, with Honeywell, with Aerocrine, and lots of others. NEC, Fujitsu. Let me specifically take the ThyssenKrupp example. What ThyssenKrupp is doing is that they're an elevator company, and so they have elevators that are constantly sending data to Azure, and by asking questions about potentially anomalous conditions, they're able to detect failures and issues with their elevator systems before these failures manifest themselves as things that would cause downtime. We all know how problematic a broken elevator can be, and ThyssenKrupp's endeavor is to ensure that their customers do not have downtime with their elevators. So by taking advantage of data, they're able to detect problems and have them fixed before they manifest themselves as larger problems that translate to downtime. Internally within Microsoft, we also have the service called the Azure Security Service, and they use Stream Analytics under the covers to detect denial of service attacks and things like that could cause downtime for some of our customers that use other Azure resources like Azure VMs and such. And by looking at patterns and asking the right questions, they're able to identify denial of service attacks and other security breaches that might be problematic and disruptive to uptime. So those are 2 examples I have, but there are numerous more.
Great, thank you, Sam, for your time today. What do we need
folks,
to do
that
to
was
wrap up the
that was
call?
all that I had.
Thank you so much, Sam, again, and Diana. So this is Sri. Wanted to go ahead and close out the call. So, the recording for this call will be available for those that can access it later, and we'll share the slide deck with you. And again, if you have any questions, you can definitely send that on Yammer. So thank you again, partners, for joining the call. See you again in the January community call. Thank you all.
Thanks.